Okay, let's find the equation. So let's draw a diagram with some toothpicks. So 1, 2, 3, 4. And another diagram, 1, 2, 3, 4. The same diagram as one off to the left. I'm going to, excuse me, move it over one. It's a little bit too close. Sorry about that. Give you time to erase and rewrite it. And now we're going to put another one off to the right. Now, how many do we add? Well, think about it. So I'm going to skip 2 squares this time and put the same shape as we already have. Whoops, I connected all the dots, whatever. Add another shape and dot, dot, dot. So first thing we're going to do is we're going to do our let statements. Let n equal the diagram number. Read the notes. I'll read it for you. The following diagrams are made out of toothpicks. In the first diagram, n equals 1. The diagram is n equals 1. You have to declare your variables. So let n equal the diagram number. Let n equal the diagram number. Write that stuff down. I don't want to write everything on the page. So if n is the diagram number, notice I could have made it anything I wanted to, d or whatever. So diagram number, each of my diagram numbers. Now let's make a table of values. So let's let's table the number of the diagram number to the number of toothpicks. I'm going to round the bottom of my t. Remember, declare your variables. Let t equal the number of toothpicks. And don't do a plus sign for t because it looks funny. So in my first diagram, how many toothpicks? Well, my first diagram off to the left, we have 4 toothpicks. The next diagram, how many toothpicks in diagram number 2? How many toothpicks did we add? Well, let's count them up. 1, 2, 3, 4, 5, 6, 7. Oh, we got 7. Oh, so it looks like we're just adding 3 each time. So in diagram 3, we're going to be 10, or count them up, or continue. So further off to the right, word problems. We're going to start off with let statements. Then we're going to do a table of values. Now we're going to figure out what the equation is. So in the notes, I've rewritten the crazy table down below on the left and showed a whole bunch of patterns. But I'm just going to continue here off to the right with our diagram that we've already done. So if you're following the notes, keep following down. If you're writing this stuff down, keep following the video. So we want to know how n and t are related. The number of toothpicks is equal to, I'm below the table of values. The number of toothpicks is equal to, I will want to try it. So I want to start off by looking at this first entry in the table. When n is 1, t is 4. Well, so I know that's just the n value 1. How do I get to 4 from 1? Well, I just add 3. Now I look at the next line and see if that works. So if I take the n value, 2, and I put it in, 2 plus 3 is 5, not 7. So we know that doesn't work. So we'll try something else. Well, t equals. Now again, we're going to look at the first line in the table, circled to the left arrow. And we know that it's 4 times n, because 4 times 1 is 4. Then we look at the second line and go, that doesn't work. So we cross it out. Then we look back at the first line circled in blue and we go, well, it's not just addition or subtraction. It's not multiplication. It must be a combination. So what would I have to do to 1 and then eventually get 4? So I want to kind of think, look at maybe 2n. Maybe 2n and go 2 times 1 is 2. What do I have to add to get 4? Well, 2, so plus 2. And then I try it on the next line, circled in blue, and I realize it doesn't work. And I go, okay, multiplication is kind of working. And then I try t equals, and I go, okay, 2 didn't work. Let's try 3n. Well, looking in like a different color, let's go for black now, circled, the first line in the table. Well, what's 3 times 1? Well, 3 times 1 is 3. What do I have to add? Plus 1. Now again, circled in black, the second line in the table, taking the n value of 2 and putting it in for n. Well, 3 times 2 is 6, plus 1 is 7. We have the equation. It's all about the equation. Whoops, I accidentally circled part of the equation. Whoops, I accidentally erased the 3 and the circle. Excuse me. That's correct. So now they're going to ask us questions like, how many toothpicks in the 10th diagram? Question mark T, n equals 10. Whenever I'm writing a question from a textbook or a teacher question, I always try and figure out a better way to write it. How many toothpicks in the 10th diagram? In the notes. Well, we start by writing the equation, the equation that we figured out off to the right just a second ago. Then we carefully substitute the n value that we know. Then 3 times 10 is 30, plus 1 is 31. And then we answer the question. The 10th diagram has 31 toothpicks. That's a mistake in the notes. Sometimes that's going to happen, excuse me. It says the 50th diagram, the 10th diagram. By this time, I might have actually cleaned that up. Be careful, I'll make a note. The 10th diagram has 31 toothpicks. Write out that English sentence. The 10th diagram. I'll probably correct, I don't know. Okay, which diagram, n equals 10, has 37 toothpicks? T equals 37. So again, this time I'm going to start off with the all-encompassing formula. Now T is 37, so I'm going to put 37 in for T, obviously. Then I'm going to do algebra, doing equations from last year, minusing 1 from both sides. So I hope that you are writing smaller than I am. Now we have a coefficient of 3 of the variable. We have to divide both sides by 3. Therefore, 12 equals n. And then answer the question. The 12th diagram has 37 toothpicks, blah, blah, blah. Then if you want to, check your answer by drawing all the diagrams, as you can see in the notes, and count up all of the toothpicks in those lines and understand way better than any teacher could ever teach you